lambda all square over 2 sigma square. Now the likelihood is f into bracket x1 to what to the variance. Now introduce your product, your array product. You have f1x f into bracket s1 over mu. So since we are introducing a product sign, that means whatever we got in f into bracket s1 over mu comma sigma square, we have to what multiply it, and that is how you got your likelihood function. Then as usual you introduce your exponential. Now it is this exponential because since it is to n, that means and so on and so forth. So our likelihood is equal to 1 over 2 sigma raised to power 2 close bracket n raised to power 2 exponential open a square bracket minus summation open a bracket s1 minus x bar close the bracket 2 plus n into bracket s bar minus mean close the bracket 2. Now we want to introduce log to both sides, so you have to insert log x to both sides and you differentiate with respect to mean, and you also equate to what 0. So you have log into bracket 1 over 2 pi sigma 2 raised to power n square exponential minus summation x1 minus x bar close the bracket 2 plus n into bracket x bar minus mu. So we have n over 2 log 1 over 2 pi plus. So the differentiation is there. You can watch the video and the explanation is there also. We have at this stage we have equals to minus then the square. Now minus we cancel minus because the initial says that we should differentiate then equate to 0. So all these are being equated to 0. So hence estimator mean is unbiased. Now we want to look for, we are still looking for the maximum likelihood. So now we want to differentiate the log likelihood with respect to sigma and equate to 0. The procedures are there on the screen and the equating to 0 are also there. You go through it, and if there is any explanation that you need, you contact us. So we have hence estimator theta is biased. However, theta is consistent. Why is my sigma biased? Because at the end of the day, my sigma gives me a negative summation and a negative n, but my sigma is consistent because it continues from the initial solution to the end, and there is no few differences between the first and the last. Now we also have another question. We are told that we should integrate 1 over theta minus x squared. We have to show it is equals to 1 over theta x. This has to do with also the likelihood functions. So the solutions are there on the screen. You have 1 over theta squared. By the time you integrate minus theta e raised to power minus theta x minus 2x over theta, then you solve mathematically. 1 we cancel 1. So then we apply our gamma rule. It is through this gamma rule, because the initial one says that it is through this gamma rule we can able to look for the answer. So we have 1 over theta times 1 over theta minus 2 times 1 over theta squared plus theta times 2 over theta raised power 3. So you pick the initial 2, you have 1 over theta minus 2 over theta plus 2 over theta, which will give us what? 1 over what? Theta squared. Now we are told to prove E into bracket differential of ln f into bracket s comma theta over differential theta. Now in this case, that is, it is equals to minus E into bracket differential raised power 2 ln f x comma theta, then differential of theta raised power 2. Now solution. Firstly, since it is raised power 2 on our left hand side, you have to what? Expand it. That is, you introduce your what? Your multiplication sign. So by that you have a differential of ln fx 10 to what? Theta dot differential of ln fx dot x 10 to what? Theta over theta over differential of theta and differential of theta. Now this and this will give us what? The denominator will give us a theta raised power 2. You just pick one of them. Now from here we have a differential of what? Ln f into bracket x change to what? Theta, close the bracket, over the differential of theta raised power 2. Now first derivative. The first derivative, we have to differentiate it with respect to theta. Differentiating with respect to theta, it will now be equals to 1 over x comma y dot df over x 10 to what? Theta over d. That is differentiation of what? Of theta. The second derivative, we have to differentiate with respect to theta again. Now when you are differentiating based on your second derivative, you have what? 1 over f into bracket xy dot differential raised power partial differential raised power 2 f into bracket x change to theta over differential of theta minus differential ln f x into theta over the differential theta dot, which is times d ln f into bracket x change to what? Theta. Then you proceed. So let's continue. From our ends, you have expectation into bracket 1 over f into bracket s tend to what? Theta. Now also, now at this stage you introduce your integral sign, and once you are introducing the integral sign, recall in integration you have to integrate, you have to differentiate twice. The expansion is there on your screen, and from our recall we are told to record that fx change to what? Theta differential s is equals to what? 1. So now you multiply by what? By 1, and by the time you multiply by 1, everything is equals to 0. Now in this case, we go back to the initial question and introduce our 0, which is there on the screen. In order to get what we are asked to prove, we multiply both sides by minus, and by the time we multiply both sides by minus, we get the what we are asked to prove based on Camara rule. You're saying? Oh, okay.
So thank you for continue schooling. Just let the record continue. Just thank you for schooling.
Thank you for taking your time to listen to us, and on behalf of myself, my humble self, HMS Joshua Odindu, and my fellow colleague, I want to say big thank you, and I want to wish you success in your forthcoming examination. Recall that mathematics is simple, and it's something that you have to do till you give up your ghost. But all you have to do is, when solving maths, you have to calm down and look at it religiously. So thank you for listening to us, and see you at the end of the journey.